Once again, my name is Dan Yeaw. I'm engineering manager at Ford Motor Company, and I'm really excited to give a talk about automating MBSE models with Gaphor and Python. Okay, so first of all, what's model-based systems engineering? What is this MBSE model thing? So this is like it's a definition from an international standard group called INCOSE. And it calls it the formalized application of modeling to support system requirements, design. And I won't read all that, but if you can imagine a model to design a system and make sure you understand what the system's supposed to do and like what requirements it's supposed to have, rather than like writing a specification or like set of Word documents or something like that. So MBSE, we use that in my day job. And it's really powerful because it has three main things. One is this like standardized language. And there's a language for MBSE called SysML, or Systems Modeling Language, that gives everyone the same language to describe a system. So if you're using a use case diagram or a state machine, it has this language and everyone knows what those boxes and lines mean, rather than someone just drawing boxes and lines on a board. It also uses abstraction, so you can start out kind of like at the very top at the trees and understand what a whole system's supposed to do. And then from each there, go down to each level and understand, like, independent of my design, that in the technical level, what is my system supposed to do? And then getting into all the technical details. And that allows you to really understand complex systems. And then the third part is about automation. And automation is really powerful, especially when we're using programming languages like Python, where we can automate things to allow for consistency and robustness of the design, and also save time. So let's talk about automation a little bit more. So automated systems have these highly repeatable effects, and we can automatically validate the designs for quality and consistency. So if we're all modeling using the same language, then we can use a computer to go through and check that the design is correct and complete and done right, and is going to work at the end. And what we're going to do today a little bit is show how we could automate some of this with Python. So there's commercial MBSE tools, and one thing that's very common in those tools is something called object constraint language. Anyone heard of that? Yeah, if you want to. Yeah, so in the room they said, like, hey, it's a programming language like TypeScript that lets you program constraints on the design or something like that, right? Yeah, so it's very similar to that. It's a little bit terse. If you look at what this OCL is on the screen, it's saying the context is a requirement, and it's looking for the text of the requirement. And then it's looking whether this text is defined. Actually, it's looking if it's undefined. And then this XOR is just this wild thing, and it's XORing with true. And I think that's really just a not statement. So it's saying a not is undefined, so it is defined. So it's using all that to say that, is this text box defined? And then it's checking that the text, the size in the box is not equal to 0. So it's, I guess, greater than 0. So it's really saying, like, hey, does this requirement have text? Is what OCL is checking in that example. But if you can imagine something a little bit more complex, it's kind of hard to figure out what it's doing. It is very powerful, though, so you can use it to put constraints to it, which are really, yeah, these rules to say, hey, all my requirements must have text, or all my requirements must be derived from other requirements, or all must be allocated to something like that, or all cars have 4 wheels, or something like that. So you can use OCL for that. We're not going to use OCL today. But that's like typically what you see in MBSE tools. Okay, so we have an example of a coffee machine, and we're going to show how to do automation to create requirements for activities automatically. If you're not familiar with an activity diagram, this is a behavioral diagram, and these swim lanes are parts of the system, and this is kind of like at a logical level, so it's independent of the actual implementation. And so if you start at the left, we're receiving the user input, and the HMI is receiving a button press, and then it's requesting coffee. So it's this behavioral diagram where you can kind of sequence through how things are going to work. And this controller here is going to command pump and heat. So it's going to turn on the water pump and turn on the water heater for the espresso machine. And then the water heater is going to feed back temperature back to the controller. And then there's parts of the espresso machine as well called a group head and portafilter to actually like pour this hot water over the coffee grounds, right? So you can detail out kind of this flow, this behavior in an activity diagram. And once you've done this, it'd be really nice to put requirements in place that the HMI should receive button presses, or that the controller shall receive the coffee request, or something like that. So while you're designing the system, you can put requirements in place, and we'll actually automate creating those requirements so you don't have to do it manually. Something else we can automate, this is for correctness of that same system. This is like a structural view of an espresso machine, and you could check that all requirements are satisfied by a block. So what that means is we said there needs to be a requirement that the HMI receives a button press. Well, we could say that that HMI block is what is satisfying that requirement. And so you're putting a relationship between like the requirement and the structure of the system. And so this is like a correctness thing. It wouldn't make any sense to have requirements that aren't linked to what's actually going to fulfill the requirement. So we can put a check in place that our model is complete and all the requirements are satisfied. Does anyone have any questions so far about coffee machines or espresso machines or activity diagrams? Any questions online, Evan? Okay, so we're going to be using a tool called Gaphor. It's open source. I'm one of the maintainers of it, and it's this multi-platform MBSE tool. It's written in Python, and it's cross-platform, so you can use it on Windows and Mac OS and Linux. And it really is kind of like this pretty easy-to-use tool that lets you do MBSE modeling, and we'll show how you can automate stuff with the tool because it's written in Python. We can actually import the tool as a library in Python and then do some of these automated checks using Python rather than writing terse OCL statements. Gaphor runs on a GUI toolkit called GTK. This is very common in like the Linux space where you see like a GUI app a lot of times, especially in the GNOME environment. They run GTK as the GUI toolkit, and the toolkit is what allows you to add what are called widgets to the screen. So that's all like your scroll bars and the things you see in the GUI. This presentation is like a GUI, right, instead of a command line interface. It is a little bit harder to set up in Windows, but I'll kind of walk through how we would set up GTK on the different operating systems so that we can import Gaphor on here. A lot of the walkthrough, I'm going to use a tool called Pipex. Probably people are really familiar with pip. That's the tool that's very common for installing packages from the Python package index. Pipex is really nice if you have like a standalone thing you want to install and make it available for all kinds of projects on your computer. And so we're going to be using Pipex a lot to like install tools like Jupyter Notebooks or so you install Pipex and then it gets installed in your Python environment, and then when you tell it to install Jupyter Lab or some tool, it's going to make its own isolated environment and then Jupyter Lab will be available across your computer for like executing. So you could install other tools like, I don't know. It's kind of like an API. It's almost like a Python installer to install tools in like this isolated environment and keep them up to date and stuff. So it's very handy. So we're going to be using that. Here's some instructions. Like in macOS, you can use Homebrew to install it. Then you run ensure path. In Windows, you would actually pip install it. And I recommend doing that to like your local user. And then running ensure path again. And then Linux is pretty much the same. So you're going to pip install local pipex and then ensure path. Okay. This is the gnarly part a little bit. Is there a train? Okay. So in Windows, we actually have to compile GTK, and there's another tool that helps us with that actually build GTK called GVS build that I help maintain as well. And I know this is a little hairy on steps to follow, but we can use Chocolatey, which is a package manager, to install some build tools like Git and MSys2 and the Visual Studio 2012 or 22 workload VC tools. So these are like things we need to use to compile GTK in Windows. And then we're going to run pipex install GVS build so that we can install this compiler for building GTK. And then we can tell it to build. In this case, we need to install GTK and some of the other libraries that Gaphor depends on. And then we're going to add these libraries we built to our path. And then this is like activating a virtual environment and installing the wheels that are built. I know that's kind of a lot. I said Windows is a little gnarly with this, but it is possible to run this in Windows. Is there any questions so far, anyone? So this is like how you would install, these are like steps to install GTK so that you can run Gaphor as a library on your computer. On Mac OS, we just run brew install PyGeometry 3 and GTK4. That's a lot easier than Windows, wasn't it? And on Linux, if you were in Ubuntu, you'd run sudo apt install, and then once again, a couple of the libraries, this Python 3 GI for geometric introspection, and then a Cairo version of that, and then the GTK4 library. Okay, so we have installed all these dependencies for Gaphor. Sorry if you're a Windows user, it's not very user-friendly, but it's possible. We'll work on making that easier, hopefully in the future. But now you can activate a virtual environment on your computer. So that's what the .vnv is in front, and then run python-m, and we're using pip install. So Gaphor is on PyPI or the PyPI for installing Gaphor, and then you just type pip install Gaphor, and then it'll install the dependencies that you need. I'm going to be using Jupyter and specifically Jupyter Lab for kind of parsing through the model. If you're not familiar with that, it's a notebook, and it's very, like, I would say, data science oriented for like looking at data and trying to figure out how to code something. And it works nice for this as well because you're kind of parsing through a model, trying to figure out like, oh, hey, what relationship should that have and stuff like that. So it's also nice for using Jupyter Notebooks for this. Yep. In the room, Xander said it stores your work in a notebook, which, yeah. Yeah, and you can execute it line by line. So if you're not familiar with that, we'll see that in a second. I'm actually using once again, I like this. I like pipx, so you can use pipx to install Jupyter Lab as well. So you can type pipx install Jupyter Lab. I would use this include deps, which stands for dependencies. Otherwise, you'll only get the Jupyter Lab command, and there's a bunch of other stuff that comes with Jupyter that you probably need those commands as well. There's lots of other ways to install Jupyter Lab, and so if you're like a Conda or kind of Anaconda environment type user because you're doing data science, then that's totally valid, and you can install it with Conda install Conda Forge Jupyter Lab. Yeah, in person, there's like some chair scraping or something. That sounds like a train or something. I don't know. A horn. Okay, so now we're going to launch Jupyter Lab so you can pip. One thing, I kind of like to do when working with these notebooks, this is probably optional depending on your usage of it, but I like to pip install this IPY kernel. This allows you to create like a separate kernel in Jupyter Lab for the project you're working on. And so then you can launch IPY kernel and install a new one. And this display name is just the current working directory and like the base directory. So if I was in like a directory called Gaphor, then the base name would be Gaphor. So this is just for creating like a separate kernel for what you're working on, but I would say it's maybe optional depending on your usage of notebooks. And then we're going to launch Jupyter Lab. All right. We made it through setup. Is everyone ready for seeing this in person? I'm not sure where my camera went off, but I'll reshare that. My screen sharing is not working, which is not good. All right, bear with me, everyone. Does everyone have any questions while I figure out why screen sharing is not working? All right, now it's going, right? I'm not sure why that was. Any questions, anyone? Okay, so we're going to launch Jupyter Lab first. So I'm going to activate the virtual environment. So I'm going to type in Jupyter Lab, right? And so this is going to launch a server locally that Jupyter Lab runs in, and then loads it in a web browser. Okay, so the first thing we were going to work on was creating a requirement. So these are these notebooks, and I've kind of pre-run some of this. Let me restart that. So at the top here, we're actually importing things from Gaphor as a library. And so these are like maybe some standard imports that we want to use. So for example, and we'll make use of these, some of them as we go. But some things like we are using this systems modeling language to actually do modeling. So we need to import that, for example. Or an element factory is used to create new things in our model. So we're importing those things. And we can go ahead and run that, right? And then the next cell here, we create a new element factory called element factory here. And then we also need to initialize this modeling language service. and we're calling that modeling language service as well. And then I actually have this model here called coffee machine. And this model, here, let me simplify this. So this is what Gaphor looks like when you open it up. So up here in the upper left, there's the modeling language you can select, and then you can open a diagram and do things like add blocks to it visually and model a system like we were showing with activity diagrams and the internal block diagram before. So this is what Gaphor looks like. So there's this, let me go to new. So we're going to select this coffee machine example here. And so this was the model we were looking at, the example model we were looking at in the presentation. So the logical structure shows the espresso machine with all the parts. And we were actually looking at the logical boundary diagram, if everyone remembers, where you have like the water tank and water pump and everything, right? And maybe let me, I guess that's okay. And then we also had this functional boundary behavior, which had the user input to the receive button press. So this is all in this model, right? That we can model. So we actually want to load this in our Jupyter Notebook. So you can see the model is called coffeemachine.gaphor, which is the model. And then we're going to open the model. So this is a context manager. So it opens the model and then we'll automatically close it for us when it's done opening it. And we're using normally we want to use the UTF-8 encoding for opening files. And then we call storage, which is part of Gaphor, to load the model file. And then it's going to initialize the model using the element factory and the modeling language that we created. So it's like loading everything up. And then on the next step, we can go through the model and actually say, hey, what are all the elements in the model from the element factory dot select? We can say, what are all the activity partitions? And those are, the activity diagram was the one we were just looking at, where these are called activity partitions because they're partitioning in swim lanes. And we're looking in the model using the code to see, hey, where are those all in the model? So this doing a for loop, so we're getting for each activity partition in all the activity partitions in the model. And then we're looking for the nodes in those partitions, and those will give us the actual activities. So we want receive button press, command pump and heat, pump water. We want to select those in the model, and then we can save them to like a list and make use of them to create our requirements automatically. So to check that we have what we need in the Jupyter Notebook, we can like print the name of each activity. And then I'm also creating this list called requirement names and appending each activity name, these node names, and we'll print it out. And you can see it went through the model and found an activity called receive button press and command pump and water and pump water. And those are the same activity names, receive button press and command pump and heat and stuff that it's in the model. So it actually loaded the model, and we went through the model and found all of the activities in the model. And what we want to do is automatically create the requirements in the model based on those activity names. So if you already have the activity diagrams, you kind of have your requirements already. So we can add them to the model programmatically and then write back to the model with those requirements added. So how do we do that? So we can create, with the element factory again, we can create a diagram. And a diagram in SysML, once again, like this is a diagram, right? This is this functional boundary behavior. So we can create a new diagram where our requirements are going to go. And then we can give it a name. So we call requirement diagram.name, requirements diagram. We can create a package, which is like a folder in in SysML, so we can create a folder for our requirements to go into and name it requirements. And then this drop function we provide allows you to drop that stuff onto the diagram programmatically. So we have this requirements package and we drop it on the requirements diagram. And then for the next step, we do another for loop. Enumerate in Python allows you to take an interval. So this is like the names, which was these names here, requirement button press, command pump and wait. And enumerate allows you to number each thing as you go. So we're going to create something called a requirement ID. So it'll start at 0, normally enumerate starts at 0 and then 1, 2, 3, 4. I think normally in SysML, we don't start numbering requirements with 0. We could. So we set the start equal to 1. So we'll start numbering them sequentially starting at 1. And so it's going to set that to the ID of the requirement. So we'll go 1, 2, 3, 4, 5. And then the name will be the name of each one of these as it goes through the for loop. And then we're going to create a SysML requirement object. And if we are on the SysML profile, that would be like us going and dropping a new requirement on a diagram. So we're going to create one of these programmatically. And then we're going to give it the name, which is these names like receive button press, command pump and heat, and pass in this requirement.external ID to the requirement. When I was going through this, it is kind of hard to know, like, hey, what is the name called and what's the ID called and stuff like that. If you go to, we have a docs website for Gaphor, and you can actually go to the modeling languages, so like the systems modeling language, and see like, hey, I'm looking at requirements, and you can see like the requirement types here. So like, for example, a requirement has a text field or has a derived field. So you can kind of see some of the relationships and what the requirement types look like. Or you can play around in Jupyter and try to figure it out as well. Or you can look at the Gaphor code if you really want to. But so external ID is the ID of the requirement. And once again, we want to drop these requirements as we go onto this requirements diagram. And I'm putting its location instead of 0, 0. If we put them all at 0, 0, they'll all be on top of each other. So you'll have like 5, 6 requirements on the diagram all covering each other. Instead, I'm just offsetting it by 125 pixels and multiplying by the requirement ID. And since they're sequential, it just makes them go to the right, and sequentially go. And then we can draw it. So this is pretty cool. And it's built into Gaphor. So we have like this draw function, which is an IPython extension. And we can actually draw in the Jupyter Notebook. So you can see here, here's all the requirements that were just created in the Jupyter Notebook. So they have the ID sequentially created. And the name of the requirement is based on these names of our activities that we created before. And it's drawing like an SVG now on the screen of what it'll look like in a model if it was a model. Finally, we can go with open, once again, our model again, which was called the coffee machine. And we open it with W for write. So now we want to write to the model. Same encoding for that. And then we do storage.save. So we're going to pass in to the save function the file we're writing to, and then the element factory again. So it's going to go and take all that information we just created and save it back to the model. Let's close our model before writing to it. And we will write to our model. Okay. So then we can reopen our model. And we should expect requirements. So you can see, and we could organize these a bit, but you can see the requirements package, and there's a requirements diagram, and it's got all the requirements we just created using Python in the model based on the names, once again, from this boundary diagram. So this is an example how you could like automate something. If you had a bunch of stuff you wanted to add to the model and wanted to do it automatically rather than manually, you can like write to a model programmatically, which is pretty cool, I think. Is there any questions before I show the next example? It stands for, the question in the room was, what's SVG? It stands for Scalable Vector Graphics. So it is, instead of like a picture where it's a bunch of pixels, it's more like lines. So it has a starting point for each line and an ending point. And then it's really nice because if you scale it really big, it still looks really good because it's just like the vectors of the lines drawn. So it's saving the lines and the boxes and the requirements as SVGs, as lines. So it looks good when it's scaled. Was there any questions online?
Hey Dan, I just have one question.
Hey, yeah.
So I'm still in the SysML learning phase, but I have one question that we should always have to start with the activity diagram to extract the requirements, or there can be other behavioral diagrams.
There's no like rule that you always have to start with certain diagrams. I do like when modeling to start with the behavior, which is like what the system needs to do. And so if we go back to even this diagram, right? I like to start with like the behavior and then draw out, okay, well, how does the structure of the system connect to create that behavior? And then kind of do requirements last, because the requirements almost just fall out of the behavior in a way. So although it's kind of a maybe fake use case I was going through of creating requirements from activity diagrams, there's something like real that I think would be useful, because I think it's nice to have your activity diagrams first, or your behavior driving your requirements. And it becomes easy to drive like what the requirements need to say as well.
Okay. So in that case, sequence diagram also I can derive requirements from them as well.
Yeah, any type of like behavior diagram I think is nice for that.
Yes. Okay.
Good one. Thanks for asking that. Any other questions? Okay, so this is maybe a little bit shorter example, and we wanted to add like an automated check, right? And our check was, do all of our requirements, are they satisfied by a block? And so we just added, if we go to our requirements diagram again, we just added a bunch of requirements. They're not satisfied by anything because we just added them into the model. They just dropped in there. But we could go to our logical level and go to our structure, and we could say, okay, the receive button press, that was the HMI doing that. So we could say the HMI is what receives the button press. And we could use a satisfy relationship. And I did it the wrong way. So we could say that block is this HMI is satisfying the requirement. And then we could do it for command, pump, and heat. So then there's a controller, right? I'm just putting these all on the same diagram and not in relationships, but for simplicity. And then for the pump water, well, the water pump's doing that. And so we're putting some relationships between the requirements and the structure of the system. So those are those like satisfy relationships. Maybe we won't add all of them, and we can save our model then. And then we want to check automatically, hey, do all of our requirements have satisfy relationships? once again, we import some of the common things, element factory and modeling language and the SysML, and we're going to create our element factory and the modeling language just like we did before, and we're going to open this coffee machine model. Okay. And then I'm running a for loop. So I'm selecting all the requirements once again, and I'm going for each requirement in the model. If the requirement does not have this satisfied by relationship, which is what it's called, and if we go back to our documentation here, you can see there's a satisfied by right here in this abstract requirement type. So if it doesn't have that satisfied by relationship, then we're going to print the requirement's name. And so you can see the requirements, the 1, 2, 3 that we added relationships don't show up there, but all the other requirements that don't have relationships are saying, oh, this doesn't have a satisfied by relationship. So this is like a simple example of how you could add these like quality checks to say, hey, every requirement needs to be linked to a block that's doing that thing and have that relationship. And then you can run checks in your model to say, hey, is that the case? And I know this example's fairly like a small example or straightforward, but imagine if you have like at Ford, we have projects with like 1,000 requirements and like complex things with like, dozens of blocks and ECUs and everything, right? So you can check across your whole model and check that everything was done consistently and correctly. So we found some issues. What else we could do is let's like load PyCharm really fast. If you're working on a model, you could also add tests. And so that's maybe the last part I wanted to show. So if you create a test, maybe in the room we're turning on the lights, but maybe I could change the light mode. That'd probably help a little bit. Darkula. Okay, and then we can, is that better? Okay. Okay, so we have this test file called test requirement satisfy, and I took the same code we just looked at in the Jupyter Notebook and loaded the model, right? We got a list of all the requirements, and then I'm passing this into Pytest, which is a test framework. And I did I parameterized the test, which means I'm passing in each of those requirements one at a time into the test to see if the test passes. And so it's the same check. So I'm with Pytest, use assert statements, and we're asserting that this requirement.satisfied by relationship is there. And if it's not, then it's going to throw a test error. And this is the error it's going to throw. So it's going to say the requirements ID / its name has no satisfy relationship. So why would you run tests against like a model? Because if you're using like we do for source control, you could put your model like in GitHub and create merge requests against your model, and you could check before each time you add changes that it passes all your like tests for the model being like correct and complete. And so that will ensure like your model quality stays high because you're running all these tests automatically on the model. So if we now run this, okay, I'm not sure how to get to the, yep, so we're going to run it. Okay, that didn't work. Let's get our, yeah, I don't know why that says the test suite is empty. Let me so if this might be a little small, but if we Pytest this test requirement satisfy, it's going to run through the tests, and you can see it's actually pretty similar to what we had in our Jupyter notebook, that it ran all these tests, and these are all test failures, that all these requirements are missing the satisfy relationship. Cool. And once again, then you could like set it up with like continuous integration and okay, so we talked about like the docs for Gaphor. So there's like docs on scripting and how to do this. You can also generate, there's a common documentation framework called Sphinx that's common in Python where you can generate documentation. You can actually, we have a Sphinx plugin, and so you can have model diagrams and add them automatically to your documentation as well, like as another thing, very similar to the scripting. So you can check that out as well. That's everything I wanted to go through. Is there any questions, anyone? Sander asked what the hardest part was. So actually some of these, like I was familiar with like modeling checks, but to prepare for this talk, I spent more time like parsing models and stuff than I had before. So just figuring out like I said, hey, what is this rec.satisfied by? What is that called or something? And figuring that out, I think really, but using Jupyter to help kind of troubleshoot that, I think works really well. So maybe that was the most challenging part, at least preparing for the talk, I guess. Yeah. Any questions online, anyone? You're all very quiet. Okay.